Last time when we met, I taught you, I did for you correction about how you can use your graph to determine solubility of salts. And I thought the corrections I had done for you would help you to complete your assignment, but some of you did not hand in still. So I'm appealing to those people, please help yourself by not being lazy. So we are still on preparation of salts. I introduced something and I want to take you through again. Most important here is the most important thing you need to know before you prepare a salt. You need to know whether the salt is soluble in water or whether it is insoluble. That is very important. Don't start out of the blue and think you can prepare just anyhow. So we said when a salt is soluble in water, we prepare it by either or neutralization. I remember telling you that, and I think you still remember. When a salt is soluble in water, it is prepared by crystallization and neutralization. You remember again in senior one, I told you, I don't know if I'm the one, but we usually tell you that when we are separating mixtures that have different solubilities, we use the method of fractional crystallization. You remember that? For example, a mixture of sodium chloride and sodium nitrate, we use fractional crystallization because those two components of the mixture have different solubilities. So it is important for you to know that. Now, having known that, we also have insoluble salts. And when I talk about insoluble salts, like I told you from the start, the solubility rules should be running in your head. If I ask you for insoluble chlorides, you should tell me. If I ask you for sulfates which are insoluble, you should tell me. Then you should know that all carbonates are insoluble, except for sodium carbonate, potassium carbonate, and ammonium carbonate. When I was teaching you, I told you to always keep that in mind. The general methods of preparation of salts. Having known that the salt is soluble or insoluble, here we are first looking at preparation of soluble salts. You said soluble salts, they are prepared by action of acid. The choice of acid depends on the salt that you are preparing. The assignment I gave you, I was very surprised when one of you used the sulfuric acid to prepare zinc chloride. When you add sulfuric acid to zinc metal, you are going to form zinc sulfate because sulfuric acid has a sulfate. So if you are preparing zinc chloride, you should be able to use hydrochloric acid. If you are preparing zinc nitrate, then you should use nitric acid. So the choice of acid also matters. Soluble salts are prepared using dilute acids and metals, or metal oxides, or metal hydroxides, and metal carbonates. So if you want, let's say copper 2 sulfate, then you can use copper metal. No, but you cannot use copper metal because copper does not displace hydrogen from acids. So you can use copper 2 oxide and you add sulfuric acid. There you will get copper 2 sulfate. Or you can get copper 2 hydroxide and you add sulfuric acid. There still you are going to get copper 2 what? Sulfate. Or you can get copper 2 carbonate and you add sulfuric acid. Still you are going to get copper 2 sulfate. So as we are going to see, you should first think, because when you are preparing a salt, you need two substances to react together. So it can be a metal, or it can be a metal hydroxide, or it can be a metal carbonate, then with an acid. And the choice of the acid depends on the salt that you are going to prepare. So general methods. I took you through these general methods. I think you still remember. Some words that should not miss in your explanation, where we always give marks. First of all, you must write an equation. When I ask you a question and say describe or explain how copper 2 sulfate crystals are prepared in the laboratory, take note, already there is 1.5 marks for the equation. So general method, place some dilute acid in a beaker. This one we looked at it. Then take note, always remember that we use warm acid. We use warm what? Acid. Because some metals take long to dissolve in dilute acid. So when you increase the temperature, you increase the rate of reaction. That one you know. So that's the reason why we use warm acid, or that's why we heat the acid. Some metals or metal oxides take long. They take long to dissolve. Yet you want all of it to dissolve. So that's the reason why we use that's why we use warm acid, or why we heat the acid. So place some dilute acid in a beaker, warm the acid and add the metal, or metal oxide, or metal hydroxide, and metal carbonate, a bit by bit, or little at a time. Instead of this, someone can say little at a time. We don't want people who do things carelessly. Until in excess. This word, until in excess, it means you add a metal or metal carbonate to an acid slowly. Whatever you add dissolves, but you are going to reach a point when the metal you are adding does not dissolve anymore. That means what you are adding is now in excess. I think you are getting that point. Until in excess, we mean whatever metal you add to the acid, it dissolves slowly, a little at a time. But you are going to reach a certain point when you add the metal, it does not dissolve. It does not dissolve anymore. That's when we say it is in excess. So someone can say, add metal little at a time until it cannot dissolve any more. To ensure that the acid is completely used up. To ensure that the acid is completely used up. Filter the metal, stroke metal oxide or metal carbonate, and collect the filtrate. So after ensuring that what you have is excess, after ensuring that what you have added is in excess, whatever did not dissolve, because I was telling you, you add until it does not dissolve anymore. Whatever did not dissolve, you filter using a filter paper. So you filter the excess metal or metal oxide, I mean the one that did not dissolve, and collect the filtrate. The filtrate is the one that goes through the filter paper. So the filtrate is the metal that dissolved, or metal carbonate, or metal hydroxide. Now, saturate the filtrate How do we saturate the filtrate? To saturate, it means to make the solution concentrated, and we saturate the filtrate. Remember, you are using dilute acid. Dilute acid means that acid contains water. So to saturate the filtrate, I mean evaporate off the water. Put that filtrate on an evaporating dish and then heat. When you heat, the water evaporates and allow the solution to cool. So after evaporating off the water, when you allow the solution to cool, the crystals will start forming slowly. To cool, as it cools, crystals form, and those are the crystals of the salt. But those crystals, they are not pure. How do we purify them? We wash those crystals by using distilled water. We wash those crystals by using distilled water. Take note. I told you this should be distilled water, not any water from the tap or what. Then after washing the crystals, we dry them. Now, I was telling you, in the lab, we may be in the lab and there is no sunshine, because there are some countries who are in winter. Does it mean they don't prepare the salt? No, they do. So the best thing to do here is to place the crystals between two filter papers. And the word place that I mean PRESS. Place the crystals between two filter papers, and that's how they dry up. So before I take you to preparation of the other salts, is there anyone who has a question about these general methods? Something that is not yet understood, because this is very, very important. And I told you, when we ask this question, we give it around 8 marks or 7 marks, because out of these steps, I've already told you 1.5 marks is for the equation. So when you don't write the equation, you know you have lost 1.5 marks. Be rest assured. Any question from you, or I proceed? You will ask the question later. Is there any question? Any question? That means everything is clear, probably, because I had even talked about this last week. So let us look at how we can prepare salts from a metal and dilute acid. For example, here, the example that we had was preparation of zinc sulfate from zinc powder. And if we are looking for zinc sulfate, as you are seeing in the equation, if we are looking for zinc sulfate, then we must use sulfuric acid. We cannot use hydrochloric acid like one of you did. Vanessa, you are the one. Vanessa, 2 North. I think you are the one who used the hydrochloric acid to prepare. No, you use the sulfuric acid to prepare zinc chloride. So that's why I was telling you. And if you are very smart, like you people, when you are preparing a salt, it does no harm for you begin with the equation, such that you know what you are using. So the other question I had given you, I wanted you to prepare zinc chloride. Zinc chloride, you should have used hydrochloric acid, such that you form zinc chloride and hydrogen gas. So the steps are clear, just like the general method. We said you begin with the acid by putting the acid in a beaker and you heat gently. I have already told you the reason why we heat. Then add zinc powder. If you are preparing zinc sulfate, use dilute sulfuric acid. Then add zinc powder to the hot acid bit by bit. But then the other thing, you must make sure here that you use the other properties of reactivity series. This metal cannot be copper. If I were to prepare copper 2 sulfate, then I cannot use this method because copper cannot displace hydrogen from sulfuric acid because copper is lower than hydrogen in the reactivity series. So take note of that. I should not tell you to prepare copper 2 sulfate, then you add sulfuric acid on copper. That reaction will not take place. So add zinc powder to the hot acid, a bit by bit or little at a time, while stirring until the zinc powder is in excess. I've told you what is the meaning of the word excess. It means until when this zinc powder you are adding does not dissolve anymore in the acid, then it means it is in excess. Then what do you do after that? Filter the excess zinc or undissolved zinc. Filter the undissolved zinc. And then when you filter, you obtain zinc sulfate solution as the filtrate. Then what do you do to the filtrate? You saturate it. How do you saturate the filtrate? Pour it on an evaporating dish and heat to drive off the water. So that's when you remain with a saturated solution. And when you remain with a saturated solution, what do? You allow it to cool because you heated it. Allow it to cool. And when it cools, it forms crystals. What do you do to those crystals? Wash them using distilled water. Distilled water is deionized water. Water that does not contain ions. Remember, we are saying hard water contains calcium ions, magnesium ions. So distilled water does not contain any iron. It is water-free iron. After washing the crystals, what do? Finally, dry them. And if you are in the lab, we said the most convenient method is to place them between two filter papers. By now, you know what a filter paper is. So let's go to this assignment that I had given you. Other salts in a similar way that can be prepared. I've already told you we have, this is what I had given you. Please, the equation 1.5. So this equation is incomplete. Many of you wrote it like that, like this. And of course, you found me when I was seeing, I did not give you the marks. This equation is incomplete. This equation is incomplete. Who can tell me what is missing on this equation? Muzachi. What is missing on this equation? Is Muzachi off? Hey, Odongo, finally you have connected the audio. Odongo, what is missing on this equation? I think Odongo does not know how to unmute. Chantal, Patricia, you are the one I'm asking. What is missing on this equation? Yes, someone has answered me with a message. What is missing here is hydrogen. We should add hydrogen. So most of you wrote it like this, and it was not correct. You see, it does not even balance. Then when you add hydrogen, you should come and put a 2 on hydrochloric acid because chlorine atoms are 2, and even the hydrogen atoms, this side will be 2. Then we also have this one. Iron 2 sulfate can be prepared in the same method. Not only iron 2 sulfate. So what do? When you want iron 2 sulfate, you are going to react iron and sulfuric acid such that iron displaces hydrogen. If you have your reactivity series, you can confirm and find out that iron displaces hydrogen. We form iron 2 sulfate plus hydrogen. So let us now look at preparation from metal oxides. Now, the challenging part here is we can ask this question by telling you, by closing it, by telling you what to use. So you have to be careful. For example, I can say, explain how copper 2 sulfate can be prepared from copper 2 oxide. That means in that case, I want you to use the oxide and nothing else. You are going to find someone again is going to say copper plus sulfuric acid. There you will get 0. Once we tell you what to use and you use something else, you get 0. So I can say, explain how zinc chloride can be prepared from zinc oxide. That means there you should use zinc oxide and not zinc metal. So preparation of salts from metal oxides, we said the procedure does not change. What has changed is, in the other case, we were using a metal, but this time we are using an oxide. So put dilute sulfuric acid in a beaker and heat it gently until it is hot. I told you the reason why we heat, members. Because this oxide, copper 2 oxide that you are going to add, sometimes it takes long to dissolve. It does not dissolve easily in dilute acid. So when we heat, we increase the temperature. And you know the rate of reaction increases with increase in what? In temperature. When temperature is high, the reaction is faster. So we heat the acid to increase the temperature or warm until it is hot. Then these steps are not going to change. What I ask you, know the substances to use. Simple as that. Know the two substances that you are going to react together to prepare the salt. Otherwise, the steps don't change. So after putting your acid in a beaker, add copper 2 oxide. Little at a time or bit by bit while stirring until the copper 2 oxide is in excess. What did I mean? What do I mean by saying until it is in excess? I told you it means until when this copper 2 oxide you are adding does not dissolve any further. Until when you add more, it does not dissolve. You add more, it does not dissolve. And in that case, we said that it means the solution is now saturated. I think you remember that. Saturated solution, the solution that cannot dissolve anymore solute. So the solute here is copper 2 oxide, and the solvent is dilute sulfuric acid. Yes. So what do you do to the excess copper 2 oxide? Filter it off using a filter funnel and a filter paper. And when you filter it off, you remain with a solution. Filter off the excess copper 2 oxide to obtain copper 2. This should be copper 2. Here should be copper 2 sulfate solution. Because copper uses a valence or uses many valences, so you have to specify this is copper 2 sulfate solution as the filtrate. Saturate the filtrate by evaporating. Or you can explain and say, pour it on the evaporating dish and heat. Evaporating, we are evaporating off the water because remember we use the dilute acid. We use the dilute acid, dilute sulfuric acid. Dilute sulfuric acid means there is water. So So after evaporating off the water, we now remain with a saturated solution. What do we do to the saturated solution? We allow it to cool. And as it cools, it forms crystals. So crystals start forming when the saturated solution starts cooling. Then what do you do? What do you do? You filter the crystals and wash them with distilled water. Then dry the crystals. I told you to ignore all this because not every lab contains an oven, but every lab contains a filter paper. So dry the crystals by placing them between two filter papers. And finally, we write our equation and we get the max. Copper 2 oxide plus sulfuric acid, we get copper 2 sulfate plus water. I think there is no question about that. Other examples of salts that can be prepared from metal oxides are, you want to prepare magnesium chloride, you can use magnesium oxide. So we can specify in our question and say, explain how magnesium chloride crystals can be prepared from either magnesium metal, because magnesium can displace hydrogen. That reaction is possible from magnesium metal. So when you are preparing magnesium chloride, automatically the acid you will use hydrochloric acid. Or I can specify and say, explain how magnesium chloride can be prepared from magnesium oxide. There I have done what? I have specified. So take note of that. And by the way, in our next lesson, we shall finish preparation of salts. And we shall have finished salts. So preparation of salts, let's now look at this. I think this one is obvious. Preparation of copper 2 nitrate. If you want to prepare copper 2 nitrate, you must use nitric acid. Nitric acid is this one, for those who don't know. So please, the choice of the acid you are going to use matters. And we are not going to tell you to use this acid or what. But for you, when you see zinc chloride, magnesium chloride, copper 2 chloride, then you should use hydrochloric acid. When you see copper 2 nitrate, you think a nitrate can come from sulfuric acid? No, you should use nitric acid. So this is the equation, and you follow the same procedures. So you only remove sulfuric acid and put nitric acid, and you get max. Preparation of salts from insoluble metal carbonates. Remember, only 3 carbonates are soluble. Please, the solubility rules. Only 3 carbonates are soluble. Potassium carbonate,
Let and sharpening.
sodium carbonate, and ammonium.
Miracle.
Okay. So, so when we want to prepare a solid from a metal carbonate, here what changes? Where we had oxide, we put there a carbonate. For example, if you want to prepare copper 2 nitrate, we shall now use copper 2 carbonate plus nitric acid. How? We shall study carbon dioxide in senior 3, carbon and its compounds. But from today and onwards, let's know that when you have an acid and you add it to a carbonate, you form 3 products. When you have an acid and you add it to a carbonate, you form 3 products. The first product is a salt. That means if you are adding copper 2 carbonate plus nitric acid, the salt you are going to form is copper 2 nitrate. Then the other products are water and carbon dioxide. So Take note of that. Pour dilute acid in a beaker. The procedure is not going to change, but what changes, instead of using oxide, we are now using carbonate. So this time we are preparing lead 2 nitrate crystals from lead 2 carbonate. So you add lead 2 carbonate a little at a time. Now, since carbon dioxide is going to be formed, I told you the products are a salt, carbon dioxide, and water. Since carbon dioxide is formed, then there will be effervescence or bubbles. I have always told you, if you feel this spelling, the spelling of this word is a nightmare for you, write bubbles. No one will penalize you. But should you attempt to write the word and you miss out one letter, 0. Effervescence occurs as carbon dioxide is evolved. This time we shall give you a mark because you are using a carbonate and the acid, and the carbon dioxide gas will be given out. So whenever you have a carbonate, any salt containing a carbonate, and you add an acid, it is automatic or obvious. Like you usually say, obviously, carbon dioxide is going to be given out. Continue adding the carbonate until no more effervescence occurs. So this is to say until the reaction stops. Until the reaction does what? Stops, or until the reaction ends. And the reaction ends when there is no more effervescence. Filter the excess carbonate to get the filtrate. Filter the excess carbonate to get the filtrate. And what do you do to the filtrate? You saturate it. How do you saturate the filtrate? By evaporating. Evaporate the filtrate by heating it gently to obtain a saturated solution. Then you cool the saturated solution to obtain crystals of lead 2 nitrate. Then wash the crystals with distilled water and dry them by placing them between 2 filter papers. And our equation is here. This is exactly what I was telling you. When you have a carbonate, this is lead 2 carbonate, and you add nitric acid, you form lead 2 nitrate. So the salt is this one, lead 2 nitrate plus water plus carbon dioxide. And this is it. This is it. So other salts, there are very many. If we are preparing copper 2 sulfate, it means we shall use copper 2 carbonate and sulfuric acid. If we are preparing barium chloride, we shall use barium carbonate and hydrochloric acid, like that. So I have to end here. Feel free to ask a question if it is there. You must understand this topic. It is a must. And I promise you, when we meet again in an exam, these questions never miss. So the ball is in your court. Any question? Feel free. The lesson is done. The first 40 minutes are done.